Okay, good evening everyone. So we will start the first class of solid-state physics. So the tutorial, this is the first tutorial classes going to happen in solid-state physics. So actually the NPTEL classes started last 1 week. So I'm going to teach the problem sections which regarding the some of the assignment problems and as well as some of the other problems which is related to the last week class. Okay, so last week started the basic crystal structure and how the atoms to solids and the quantum numbers and the crystal symmetry, like the basic brevis lattices and etc. So we are going to discuss much more on those. So each question one by one we will discuss. If you have any doubts, please let me know. So I will stop the problem and we will discuss on it. Okay. So first let us move to the first question. So the question is, the linear coefficient of thermal expansion of a material is related to the shape of its, first option, binding energy versus interatomic separation curve. Second one, binding energy versus temperature curve. Third one, force versus temperature curve. And fourth option, van der Waals force versus interatomic separation curve. So what will be the answer for this? So here the answer of this question will be A. So the linear coefficient of thermal expansion of a material is related to the shape of its binding energy versus the interatomic separation of the curve. So the second question is, in case of a covalent bond formation, if atom has 6 valence electrons, then this can covalently bond at least 2 other atom, 3 other atom, 4 other atom or 6 other atoms. So the question is, if it is a covalent bond formation, okay, any atom has 6 valence electron. The atom has 6 valence electron, then how the covalently can bond it? It can be, which option will be the correct? So here, so if it is a covalent bond and 6 valence electron, atoms will be 2. So the total atom will be 8 in an orbital. So at minus 6, it will be 2. Those 2 covalent bond to other atoms can be accommodated means can be covalent bonded with that. So in this question, in the case of covalent bond, the answer will be 2, the first option. Now we will go to the next problem. So next problem is, consider a physical constant given below and calculate the time taken by the electron revolve the first Bohr orbit of the hydrogen atom. Okay. So here, what is the given? So electronic charge which is given, the electronic mass and Planck's constant and speed of light and permittivity of species. These are the physical constants which is given. Then you have to do the calculate the time taken by electron to revolve the first Bohr orbit of the hydrogen atom. Okay, options are given. So how to do that? So we know that time t is equal to distance by velocity. Okay, so distance, like atomic orbital we are considering as a circle, then distance it will be the circumference, so that we can get it from the circumference of the circle. So that will be 2 pi r, and the will be velocity. So and velocity we can get it from the, already we know that Bohr condensation, so that will be mvr is equal to nh by 2 pi. From here we have to get the v value, so nh by then it will be 2 pi r divided by nh and multiplied by 2 pi mr. It will be 4 pi square mr square by nh. Okay, now just see that these many constants, actually mass, radius and h value, everything is given in the question. We have to just substitute, and we have to know what is this r. R is the Bohr radius. Okay, so r is Bohr radius, so that you must be know that the value r is equal to 2 this will be meter. So our question is for hydrogen atom. So N will be 1 and Z will be 1. So R will be 5.29 into 10 to the power minus 11 meter. Now we have to substitute those all values in the time equation. Then we will get the answer. So please substitute it and let me know. Then we will discuss the answer here. So after substituting, so you have to substitute here, so it will be like 4 times 3.14 whole square times 9.1 into 10 to the power minus 31 times 5.29 into 10 to the power minus 11 square whole divided by n will be 1, so h is 6.6 into 10 to the power minus 34. Then finally we will get the answer B as the answer, so it will be 1.51 into 10 to the power minus 16 seconds. So this is like a very simple problem, so it's just you have to use the basic formula, time is equal to distance by velocity, and you have to use the formula for the Bohr magnetization and the normal distance formula from the circumference of the circle. Then just substitute the physical constants whatever they given, and if you know what is the Bohr radius, then you will get the answer of this question. So we are moving to the next problem. So the question is, how much energy is needed to excite an electron from the ground state n is equal to 1 to n is equal to 4 level of hydrogen atom. So options which is given here, 12.75 electron volt, 13.60 electron volt. So this one also very simple. If you know about the hydrogen atom and its energy, then you can solve it. So we know that hydrogen atom energy En is equal to minus 13.6 into Z squared by n square electron volt. So whatever they given, n is equal to 1 and n is equal to 4. So we have to write E4 minus E1, that is equal to minus 13.6. So here it's hydrogen atom, so it will be 1. So the first term will be 1 minus 1 over 60. 15 by 16 into 13.6. So just calculate it, it will be 12.75 electron volt. So this will be the answer. So first option will be the answer. Please go through the problems, and these problems are quite simple, like very basics of that. these two are the simple problems. So we will go to the next problem. So it's like a theory question. So the question is, ionic bond formation occur in the solid when atom of metallic element easily give up their valence electron to the non-metallic atom. The option is when two adjacent atoms shares their valence electron to each other. Option C is when valence electrons are free to drift throughout the entire material. Option D is none of this. So which one will be the answer for this? So what is the normally happening in ionic bonding? Ionic bonding, in case of ionic bonding, it is always the trend in that compounds are composed of the metallic and non-metallic elements. Okay, some atoms of the metallic elements easily give up their valence electron to the non-metallic atoms. So in this process, all the atoms acquire stable or inert gas configuration, and in addition, an electrical charges also. So that is the option A is correct, when atom of metallic element easily give up their valence electron to the non-metallic atoms. If it is sharing, that will be the covalent bonding. Another one is dipole kind of bonds. Okay, so the option in this case, it will be first option. So the next question is the basic questions. How many different type of primal or chemical bonds are found in solids? 2, 3, 4, 5. What are the different kind of bond in the solids? That's the question. So the primary or chemical bonds are what? What are the different bonds in the solids? The first one is ionic bond. The second one is covalent bond, and the third one is metallic bond. So there are three kind of bond. So the option answer will be option B. Now we will go to the one of the problem section of well, apart from the theory. So here the questions: found out the quantum mechanically the magnitude of angular momentum of the electron in the first excited state of the hydrogen atom. Okay, so here sir already taught you people regarding that angular momentum in the first class itself. So it's related to that angular momentum, that's like L and S, and it will give the J value. Okay, so here the n value will be 2, like 2 states, so n value will be 1. Okay, so we know that when n equal to 2, the L value will be 0 and 1, and we know that S is equal to half. Okay, so now we have to know the coupling. So L at J, that's equal to L plus or minus S. So we know that when L equal to 0, then J value will be half. Okay, so now here for the one case that L is equal to 1, what will happen? 1 plus or minus 1 by 2. So the answer will be 1 by 2 and 3 by 2. So these are two J values for L is equal to 1. Now for 1 by 2 and L by 2, 3 by 2, we have to calculate the magnitude of it, J. Okay, so magnitude of J will be what? J plus 1, that will be root of J into J plus 1. Okay, so this is the magnitude for the normally for the angular momentum, which we are calculating always the magnitude of the angular momentum. There will be h cross also. So now substitute the values, half into 1 plus half h cross. So 1 will be root 3 by 2 h cross, and another one is what it will be, root of 3 by 2 into 3 by 2 plus h cross, plus 1 h cross. It will be root 15 by 2 h cross. So the answer will be option A. So the question is the angular momentum of the electron in the first excited state. Okay, so first you have to calculate what will be the n value. From the n value you have to calculate L and S. From the each corresponding L value you have to calculate the J value, angular momentum. Okay, and for finding the magnitude of that we have to do root of J into J plus 1 h cross, and substitute both cases. L is equal to half and L is equal to 3 by 2. J is equal to half and J is equal to 3 by 2. Then you will get the answer for the question. So please go through it and ask if you have any doubt. So please go through it. So we are only solving very basic problems like it's like a very fundamentals like how the crystal structure. That next problems are coming related to that, but now we are discussing the basic quantum mechanics problem, the quantum numbers and angular momentum of the electron in the atoms. Now we are going to solve the next problem. So this part is also which covered in the week first week actually in the first week classes. So the question is, if the potential energy of function for a solid crystal is expressed as U of r is equal to minus a by r to the power 6 plus b by r to the power 12, then find out the potential energy of a crystal at equilibrium separation. At equilibrium separation, the attractive and repulsive forces between two atoms in the solids become equal. So, what is equilibrium conditions? They are given that. So, options are like minus a square by 2b and option B is minus b square by 2a, option C is minus a square by 4b, option D is minus 2a square by 3b. Okay. So, these are four options. So, what is given? The potential, which is U of r is equal to minus a by r to the power 6 plus b by r to the power 12. Okay. So, this is what it is given. So, equilibrium separation condition is what? So, normally what will happen when r is equal to r0, we will achieve the like equilibrium condition. So, then the potential energy become U of r0. Okay, so the derivative of the potential energy, that is du by dr at r is equal to r0 is equal to 0. Now what we have to do? We have to find the first derivative of this potential and that equate it with 0 first. So find the derivative first, then we will discuss the how the values. Okay. So first take the derivative of minus a by r to the power 6 plus b by r to the power 2. So what will be the derivative for this? Minus a times minus 6 r to the power minus 7 then minus b into 12, then r to the power 30, that is equal to 0. 6a r to the power 7 is equal to 12b r to the power 30. Now what will happen? So you have to calculate the r in terms of a and b. So we will get 2b by r to the power 6 is equal to a. R to the power 6 will be so it will be 2b by a. Okay. R will be 2 minus a divided by 2b by a plus b divided by 2b by a. You will get to simplify this term, you will get this is like you have to just substitute the first derivative is 0 and find the r value, substitute that r value into the potential and solve it. You will get a expression like this. Okay. Now this is actually saying about the potential. So in a solid, so total force which is consisted of two part repulsive and attractive, that is repulsive force plus attractive force. So here 1 by minus a power r to the 6 and 1 by b power r to the 12. So it will be like one is attractive, one is repulsive. So here it will be going like this. So this r is equal to r0. So for equilibrium condition, what you have to do, you have to take the derivative with respect to r, then equate with r0, then give r0, then you will get the equilibrium. So please go through the problem. Okay, now we will go to the next formula. These are two small theory questions. So, a secondary bonding or van der Waals bonding in solid material between molecule and molecular structure that are covalent bonded, ionic bonded, metallic bonded, or none of this. So, they are asking like how the van der Waals bond will be, in the which form. It will be like covalent bond form, or an ionic bond form, or a metallic bond form. So, the secondary bonding is like evidence for the inert gases which have the stable electronic structures. Okay, so and in addition between the molecule in molecular structure that are covalent bonded. So hence the option is A. So the normal van der Waals by weak bond, secondary van der Waals in solid between the molecule in molecular structure that are covalent bonded. Okay. So now see the next question. It's also like van der Waals bonding is formed due to electron and ion course interaction, dipole interaction, Coulomb interaction, or sharing of electrons. So what one will be the van der Waals formed due to the dipole interaction. So that is the answer for that question. So the next question is, which is similar to the question which we have discussed here, this same kind of. So the question is, assuming the equilibrium separation of two atoms to be 2.8 angstrom and dissociation energy, that energy which will be given out in the process of formation of a crystal by bring neutral atoms from infinity to the position of equilibrium, or it is defined as the energy required to separate the atom from equilibrium separation to the infinity distance, that is given by 8 into 10 to the power minus 19 joule. So we have to calculate the value of A and B in the expression of potential energy U of R, that is equal to A divided by R to the power 9 minus B divided by R. Okay, so this is the question. So what is the dissociation energy? The energy which will be given out of the process of formation of or a crystal to by bring neutral atom from infinity to the position of equilibrium. Just nothing but it is also R0 value. At the R0 value, what is the energy that is given by dissociation energy. So what we have to do, du by dr at R is equal to R0. So it will be that has to be 0. So this will be the expression. So we have got the relation between A and B. So we have now already the we'll substitute R0 value. If you simplify it, you will get 8 B by 9. This is one method. If we approach in different way, like here actually what I have done is like I substituted a from this equation, okay, from the our basic equation here, okay, from this I have substituted here, then I have converted that into joule in electrovolt, and the R0 will be 2.8 angstrom. Okay, so that angstrom unit only given in the question also. So now substitute all these values. What we have to do, we have to so first this and find the value of b. So I am writing here the remaining things. Find the value of b here, okay. So your b value will be like around 15.48, and from the using that b value substitute in the formula here, and then you will get the a value after. So the answer will be A. So be careful this question. It's very simple question, but you have to do the derivative and equate, find the constants value. So that is the only part to do in this problem. So go through it carefully and please ask if you have any doubt on this. are going to the next problem. So next problem is I think you have already read about the unit cell lattice and all. This problem is related to that. The question is, how many unit cells are there in 1 gram of NaCl crystal? So consider in each unit cell of NaCl crystal having 4 molecules of NaCl. Okay. So we know that NaCl is crystal, it has unit cell. So the question is, how many unit cells are there? Okay. So 4 molecules is giving 1 unit cell. So that is given in the question. Okay, so this we have to approach with the mole concept. So it is, so we have to know what is number of moles. So here weight divided by okay, so this will be the number of moles. So number of molecules. So that will be we have to multiply this number of moles by Avogadro number 610 into 10 to the power 23. So these many molecules are there in 1 gram of NaCl. Okay. Now we have 4 molecules. So giving 1 unit cell. So we have 1.03 into 10 to the power 22 molecules. So it will be 1.03 into 10 to the power 22 divided by 4. So these many unit cells are there. So these many molecules, like 4 molecules in 1 unit cell. So these many molecules means by 4 you will get the total number of unit cells. So see, it's a very huge number, that is 10 to the power 21 or power order is there, means it's so every crystal which will be consist of any number of unit cell which is a unit like arranged or pattern. Okay, so that is the answers. Please go through this question, then we will go to the next one. go to the next problem. It's two theory questions. That is, hydrogen bonds, special type of secondary bond are stronger than ionic bond. All other types of secondary bonds or van der Waals bonds, metallic bond or covalent bond. So which one will be the magnitude of the hydrogen bond is generally greater than that of the all other type of secondary bond, and that will be the value higher as 51 kilojoule per mole, that is 0.52 electron volt per molecule. So then the option be all the bond, the secondary bond or the van der Waals bonds. And see the next question. The primary bond or chemical bond is found between the atoms, between the molecule, between the atoms and molecule, none of the above. So what will be the answer for this? The primary bond or chemical bond is found between the atoms. Okay. So option A is correct one. go to the other two kind of problems. Here the question is, in an atomic structure, maximum how many electrons can put in filling the form of from the lowest energy up to principal quantum number n is equal to 4. Okay, so here to n equal to 4. So to calculate the un square. So maximum electrons will be this much can be put. So here then it will be 2, here 8, then 18 and 32. If you add up it will be 60. So the answer will be 60. It's very simple question. You have to just know the 2n square, that formula, to check the maximum number of electron can be accommodated in orbit. So see the next question and think about it, how to solve it. Okay, so that's also very simple question and very fundamental basic question of that. So the question is, an electron is an atom revolves around the nucleus of orbit of radius r, and that is equal to 1 angstrom. So radius r, which is given here, that is equal to 1 angstrom. So calculate the orbital magnetic moment if the frequency of revolution of the electron is 10 to the power 10 megahertz. So frequency, we have to calculate the orbital magnetic moment. Okay. Basically we know how to calculate the magnetic moment. It's equal to I into the area. I is the current and A is the area. Area, it will be pi r square because we are assuming the orbital circle. Okay, now what about the current? So it can calculate from charge per time. Okay, so here charge is E, time, and time like 1 over time, that is frequency. So it will be 10 to the power 16 hertz. So it will be given the frequency, that's EF. That will be current. Now so this mu will be the orbital magnetic moment. Okay, because we are calculating. So it will be into area. So it will be D option will be the correct answer. So please go through it, then we will discuss the next question. Next question is very simple, that is, among the following bond, which one is the weakest one? Covalent bond, ionic bond, metallic bond, or van der Waals bond? So the answer will be the van der Waals bond. So first is the weakest bond. So that we know already. So the van der Waals bonding is the weak bonding. question. The net potential energy between the adjacent ions En may be represented by the equation En is equal to minus A by R plus B by R power n. Calculate the binding energy E0 when the terms of the parameter A, B and N using the following procedure. Okay, so differentiate En with respect to R and then set the resulting expression equal to 0. That is giving the hint how to solve it. Okay. So how to solve it? You have to take dE by dr, that is equal to 0. So take the first derivative of it. Then you have to find the R0 value. When En is equal to E0 at R is equal to R0. Then E0 you can easily find it. Then you can check which option is correct. Then you will get the answer for that. So you have to solve like dou En by now we have to do like at En is equal to E0 at R is equal to R0. Okay, so then E0 will be this will be the answer. So option B will be the correct answer here. So both of this, it is very easy problem. Just only substitute and keep it as it is. Options will be already there, so you can match with the options like that. to the next problem. In tetragonal crystal, the type of Breville lattices available are. So we have already studied about the different crystal system and its Breville lattices also. There are total 14 Breville lattices. So 7 systems are cubic, tetragonal, orthorhombic, trigonal, hexagonal. Okay, so etc. So in that, which one? So each crystal system we have the centering. Okay, so symbol system will be, crystal will be in the all. Okay, so if you see the cubic system, see the all atom will be in the like if you are saying about primitive system always is the simple one. Okay, all atom in the corners. But if you see the cubic system, there will be symbol, body centering also possible, face centers also possible. Similarly, tetragonal system, it will be symbol and body centered. Okay, and face centered means the atoms which is shared in the faces, and body centered the atom which is completely inside the unit cell wherever we have the system. And symbol, like symbol means each atom is shared in the every corner of the cubes. Okay, so as we know, it is in tetragonal system, it is simple and body centered. Next question also similar to this. Identify the type of crystal for following lattice parameters. So the question like A not equal to B not equal to Z, and alpha is equal to gamma is equal to 90 degree, that not equal to beta. This is for like see orthorhombic, A not equal to B not equal to C, but alpha gamma is 90 degrees. So here alpha and gamma is 90 but not equal to, so the answer will be monoclinic. So monoclinic it is. So in orthorhombic and monoclinic and triclinic, A not equal to B not equal to C. So we have to only consider the angle then to check the difference between the crystal systems. Okay. See this question also similar to the question which we have done already. The potential energy energy function is expressed as u of r is equal to minus a by r cube plus b by r to the power 7. Find the distance r0 at which potential energy will be minimum. Okay. So here also you have to do du by dr, that r is equal to r0, that is equal to 0. So if you calculate, it will be minus of minus 3 and p r to the minus 4 7 p r to the minus 8 is equal to 0. So it will be dA by So this is the main problem which we have solved today, like using same formula, like we have to at the equilibrium condition what will be the potential energy. So in the equilibrium condition, what will happen when r is equal to r0? Equilibrium condition, the potential, the first derivative of the potential energy with respect to r, it will be 0. So equate it and find the a by b relation with respect to r. Substitute. Some cases you have to find the r value, some cases you have to use the back the r value to the back and find the answer a and b value and find the answer at r is equal to r0. What will happen in that? Okay, so these questions are very important in this part. So you can may get a problem in your exam also. So regarding this in your assignments also. So you can refer this problem to solve your assignments. Option B will be the answer. We'll go to the last question of this section, today's section. What is the relation between the spin angular momentum s of an electron and the spin quantum number? Okay, so the options are like root of s into s plus 1, h into root of s into s plus 1, and hs into s plus 1, h cross into root of s into s plus 1. Okay, so if you see this, that we already know about the angular momentum, and there are two kind of angular momentum, and L and S. S is the spin angular momentum, and the answer is like h cross square, h cross into s into s plus 1. So it's a straightforward answer. Okay, so this will be the answer. So we will just go through the questions whatever we have discussed today. Okay, so this is a like normal. So linear coefficient of thermal expansion of the material with respect to the shape, like everything whatever we have discussed in between the interaction between the atoms and electrons, how the bonds will be, that are the first few questions, and how many the covalent bond formation, how many valence electron will be forming, like that kind of questions. And here this is the one of the important questions what we discuss here regarding the in which includes the Bohr equations, and we have to calculate the time period, time taken by the electron revolving in the first Bohr orbit of the hydrogen atom. And this question actually you can clearly see that like just simple questions from electron will transfer from one level to another level, what will be the energy difference between that, okay, exciting energy for that. And this is the like basic bonding basic question. There are some few basic questions related to the bonding regarding the ionic bonding, how it will be the covalent bonding, and what will be the weakest bond, how the bond will happening, and how what is the primary or chemical bond, what is the secondary bond. All these kind of questions we have discussed today. And this is the one of the questions which is related to the angular momentum of the systems. As we already know that there are two kind of momentum, that is L and S, and spin orbital angular momentum, spin angular momentum. How will be the total angular momentum and how to find it? Well, if you know the first excited means orbital, then from there you have to calculate the L value, from the L value you have to calculate the J, from the J value you can calculate the total J value of the total magnitude of the J values. And see here, this is the another kind of problem like which we have discussed here. Say these kind of 3 or 4 problems we have discussed here, that already the potential thing that I have explained already for that. And this is like normal bonding problems, and here is the one of the other problem. But this kind of problem, it's you have to remember that you have to take the first derivative, that if it is wrong then all problem will get wrong. So the first derivative and equate with that with 0, then find the R0 value, substitute into your normal potential, then find it of the answer of it. Okay. And this is like another kind of questions. Here you should know the basic chemistry part also, like how the number of moles calculated and number of molecules from the number of moles, and Avogadro number value, and from the unit cell how will the number of molecules it will be there. Okay, so that you should know about it. And the another type of bonding, that is hydrogen bonding, how the hydrogen bonding will work. That's also one of the question what we have discussed. And the number of atoms, max number of electrons which will be filled the lowest energy to the principal quantum number when n equal to L. The total number of atom, how much it can be filled. That also one of the questions which I have given here. This is another one, magnetic moment calculation. So magnetic moment formula we already know, that current into area. So we have to calculate what will be the area and current value. Current value we have calculated from the time. Okay, and the next one is whatever we have discussed, it is the ionic and covalent bonding and van der Waals bond. And this is another one, the potential problem. And here we have discussed about the normal crystal structure and its formula, its means basics, so that you should know in about the all the crystal structure how it will be. And another one is same potential problem, and this is the like basic angular momentum problem. So these are the problems we have discussed today. So we will wind up the class today. We will meet the next week same class, like with the tutorial second. Okay, thank you so much. Bye.